in two variables is an ordered pair x comma y that makes the inequality true. I feel like we already actually did these types of things before in the beginning of the year, but we're going to be trying them again and showing how to determine if an ordered pair is a solution, both algebraically and using a graph. So the first question is asking us to determine if 0, 0 is a solution of that inequality, y is greater than negative 2x minus 4. And they want us to show this algebraically first and then using the graph second. So to use algebra means to take the inequality y is greater than negative 2x minus 4 and replace 0 for x and 0 for y to see if you get a true statement or if you get a false statement. So when I replace 0 in for x and y, because that's the point they want us to see if it's the solution of, this will say 0 is greater than negative 2 times 0 minus 4. Once I go to solve this, negative 2 times 0 is just 0, and I will be left with 0 is greater than 0 minus 4 is just negative 4. Then we have to determine if that's true. Is 0 greater than negative 4? Yes. So because this is true, that means that 0, 0 is a solution. That's how you would determine it with algebra, by replacing in the ordered pair to see if it worked. To figure out if it's a solution graphically, we would have to graph the inequality by plotting first the y-intercept. Here's the y-axis. We would start at negative 4, so 1, 2, 3, 4 down here. We would use the slope to get to another point. The slope is negative 2, so from here we would go down to 1, 2, and we would go over 1. And once we have our 2 points, then we have to figure out what type of line to use. This is all depending on the symbol that's in the inequality. This symbol is greater than. What type of line do we use for greater than symbols? Dotted. Yep, dotted. So you can either continue on with the pattern and keep going down 2 over 1, down 2 over 1, and just do all the dots that you can. Or you can, instead of drawing a straight line, you can draw a dashed line through it. It's not going to be perfect because we don't have rulers, but you can just show me that it would be a dashed line, not a full solid line. And then the last thing that you would want to do is figure out the shaded region to see if 0, 0 was a solution. So 0, 0 is a funny one because we actually would probably use this anyway to determine if this is a solution. So if we were to replace 0, 0 in, it would actually just be this anyway. So I feel like graphically it takes a lot more steps. But we would end up finding that anything bigger than the line would be anything over here. So because 0, 0 is in that solution region, the answer would be yes, that 0, 0 is a solution. So the answer would be yes, it is a solution because both things showed that it would be. Graphically, once we graphed the inequality, we saw that the 0, 0 point is in the solution region. Algebraically, which is actually a little bit easier and quicker, you just replace the point in and see if it's true or not. If I gave you another question and I said, is like, let's say 5, 0 a solution to this inequality, would that be true? Look at the point. I'm just giving you a random point. The point 5, 0. Would 5, 0, without even doing any work, would 5, 0 be a solution to this inequality? Yes. I see some nods, yes. How can we tell from the graph that 5, 0 would be a solution to this inequality? Serena? Yeah. So if you look at the point here, it's going to be in that shaded region. Any point that's in this shaded region would be a solution. So it's as easy as that. So what I want you guys to do, if you haven't already started, try the next one. The next one you will have to first solve. Well, the first thing you want to do, if you wanted to do the algebra first, is you would replace negative 1 for x and 9 for y to see if it works. And then when you go to use the graph, you would have to solve for y before you can graph it. So take a few minutes, try number 2. We'll go over the answer and then we'll move on.
Yeah, I'm trying to. Oh wait. I'm trying to figure it out. So I don't know what to do after that part.
All right, so let's go over this and see how you guys did. So first thing we're gonna do, if we're gonna try and figure this out algebraically, is we're gonna replace in -1 for x and 9 for y. When I do that, this is going to say 2 times -1 plus 9, and then we're going to see if this is true or not, if it's less than -3. Well, 2 times -1 is -2, and -2 plus 9 is 7. Is 7 less than -3? No. So I already know from using algebra that this point is not going to be in the solution region for this inequality. To show that by graphing, I would first take 2x plus y is less than -3, and I would solve it for y to put it into slope-intercept form. To do that, the first thing I would do is only just subtract 2x from both sides, and I'll get y is less than -2x minus 3. This is what I will graph on that graph over here to the left. Where will I start my graph at?
3, -3.
Yes. -3. So on the y-axis, I'll go down to 3 here. And then from here, I have another -2 slope. Like a lot of them have been this. And then I will draw my type of line. Solid lines are for less than or equal to or greater than or equal to. Dotted or dashed are for less than or greater than. Because this is just a less than, I know that the points on this line are not solutions. So I'm just going to draw a dashed line. It's not perfect, but it'll do. And then I need to figure out where the solutions are for this graph. Now, we could actually use this idea. We already know that this point is not the solution in the solution region. So if I look for where -1, 9 is, 1, 2, 3, 4, 5, 6, 7, 8, 9, I know that this point is not a solution. So because I know that already, where will the solutions be? On the other side. So I don't actually have to do any more work. I could use this idea that we already know that this point's not a solution to show where the solutions must be, which would be on the other side. Okay, so that is just a refresher on what we learned yesterday and how to solve linear inequalities. What we're going to do instead of doing this next practice problems is skip a couple pages in our packet. I want you guys please to open up to where you see these word problems here. It says modeling with mathematics. So we're going to start some word problems today, and it's really important to understand not only how to graph these things and solve them, but also how to apply it to real-world situations and solve a word problem about it. So here's the first one. You can spend at most $10 on grapes and apples or a fruit salad. So I'm going to just start underlining things that I know is important. So we can spend at most $10 on grapes and apples for a fruit salad. So we're buying two things. We're buying grapes and apples. They tell us that grapes cost $2.50 per pound and apples cost $1 per pound. They want us first to write an inequality that represents the situation, and then they want us to graph it. So in order to write an inequality, we have to realize that whenever we're working with these types of problems, we're going to have two variables. We're always going to use x and y. So if they don't tell us what x is equal to or what y is equal to, then what I like to do is whatever the first thing that appears in the word problem, I like to use that as x, and the second thing for y. So the first thing I read is grapes. So I'm going to let x be grapes. And the second thing that I read about is apples. I'm going to let y be apples. Now that I have my variables picked out for what they represent, the next thing I'm going to do is create the inequality. There's three things that I have underlined. They can spend at most $10 on grapes and apples, and they tell us that grapes cost $2.50 per pound and apples cost $1 per pound. So I know that this person or you only have $10 to spend. You don't have to spend exactly $10 though. So if you have any amount of money, you don't have to spend exactly that. You can always spend anything that's less than that or up to that. And we know the cost for grapes and the cost for apples. So to create this inequality, if X represents the number of grapes, and I know grapes cost $2.50 per pound, this would be 2.50 times X plus the price for apples. The price for apples is $1 per pound for each apple, so you can either put 1Y or you don't have to include the Y at all, or you don't have to include the 1 at all, you can just include the Y. This represents how much it costs per grapes plus how much it costs per apples, and we know we have at most $10. Now usually we would put an equal sign here, but because this is not necessarily how many can you exactly get to equal $10, and this is more like here's the amount of money you have, you can spend up to this, you then have to figure out what symbol to use. So the 4 symbols would be less than or equal to, greater than, or greater than or equal to. Which symbol makes the most sense that you can spend at most $10?
Is it less than
Yes, it's going to be less than, but it's also going to be something else.
or equal to?
Yes, perfect. Why will it be less than or equal to and not just less than? Because I agree with the less than, but why can we add the equal to part to it?
Because you could spend $10.
Yes, because you can spend exactly $10 because that's the amount of money you have, you would need the equal to part as well. But great, the idea that it's less than is a skill that we need to understand. Now that we have the inequality, now it's time to graph it. In order to graph inequalities, we need to take whatever format they're in and put them into what form? Yeah, y equals mx plus b form, which is slope-intercept form. So we're going to take 2.50x plus, I'm just going to get rid of the 1, plus y is less than or equal to 10, and I'm going to solve this thing for y. Thankfully, it's pretty easy to do. All we have to do is subtract 250x from both sides. And when I do that, these cancel, and I will have y is less than or equal to, I'm going to write the negative 2.50x first because that's the slope. And then plus 10, the positive 10. So this is the inequality that we're going to graph on that graph right there to the left. So to graph that, we need to start at our y-intercept, which is this number right here. So we're going to start on the y-axis at 10. Now notice this graph looks a little bit different. Usually the graphs we've been working with were 4 quadrants. This one is only the first quadrant here. And the reason why is because since this is a word problem, the only numbers that make sense are positive. And all of the numbers that are in this quadrant are all positive, which is why the other ones aren't there. So we're going to start here at 10, and then we're going to use our slope to get to another point. Now the slope is negative 2.50. So we can think of this a couple ways. We can think of that as negative 2.50 over 1. Or we can think about what fraction that actually is. Negative 2.50 is the same thing as negative 5 over 2. Either way, if you went down 2 1/2, you would go down 2 1/2, 1, 2, and a half, and over 1 and get to another point. Or you can go down 1, 2, 3, 4, 5, and over 2, and it'll give you that same line. So however you think of it, if you know 5 over 2 is 2.5, then that might be easy for you to convert. If not, you can always go down 2 1/2 and over 1. It's just not going to be as accurate. But with this section, it's really not going to be that accurate because we're graphing inequalities. So the last thing that we would do is pick, 2 things to do. We first would pick which type of line we would need. What type of line would we need for this one? Solid. And just to finish this out, I'm going to go down to 5 and over 2. This is going to be a solid line. And then the last thing, final thing we're always going to do is shade. So when we're shading inequalities, you still follow the same exact method. Pick any point to test. 0, 0 can be used. It's right here at the corner. And I can quickly test 0, 0 by replacing 0 in for x and 0 in for y. And when I do that, this whole thing turns into 0 since 250 times 0 is 0. This whole thing turns into 0 as well since 1 times 0 is 0. So we're going to get 0 plus 0 is less than or equal to 10, which is just 0 is less than or equal to 10, which is true. Since 0 is less than or equal to 10, that means anything that's on the same side as where that point is a solution. So the solution is everything inside of the line here, which is like that triangle part. So if I scroll down, I'd have to erase everything. So the last question here asks us to identify two solutions of the inequality. And that means pick any two ordered pairs inside of the solution region and write about what they mean. So I can choose anything. Give me a point that's inside of that shaded region. Connor? 5, 2's not. 2, 5. 2, 5 is. Alright, so 2, 5 is a solution. So let's talk about why. So it's right there on the border of being a solution. So 2, 5 is a solution. I can tell because it's in the solution region for one reason only. I'm going to show you this one algebraically. So I'm going to use the inequality up here, and I'm going to replace a 2 in for x and a 1 in for y. So when I do that, I'm going to get 2.50 times 2 plus 1 times 5 is 5, and see what happens. So 250 times 2 is 5, and 5 plus 5 is 10, and this is true. 10 is less than or equal to 10. There's only one reason why this is true, though. What makes that true? What made that true? Yes. This part right here, the reason that this is true is because this equal to part. If this line was a different type of line, if this line was a dashed line or a dotted line, this point would not be able to be used. But because it's a solid line, it means that all the points on this line are solutions as well. So what does this ordered pair mean according to the problem? Remember, x represents pounds of grapes and y represents pounds of apples. What does 2, 5 represent? Anyone? So in this situation, Molly? Exactly. So you can get 2 pounds of grapes and 5 pounds of apples and still spend less than or equal to $10. This is actually going to be equal to exactly $10, but that will work. Somebody give me another ordered pair that is in the solution region that we can just double check to make sure works. One more ordered pair. Anyone? Serena? 0 what? Yeah. So if I go to 0, 4, this point right here, this is in the solution region since it's shaded here. And let's verify that by taking the point 0, 4 and replacing in 0 for x and 4 for y. So if I put 0 in for x and 4 for y, 250 times 0. Oh, it's okay. 4, 0 will work, and so will this. They both will. So if I do this, I'm going to get 0 plus 4, and this is true. 4 is less than or equal to 10. You can get no grapes in this case and 4 pounds of apples and still spend less than or equal to $10. So what I'm trying to show you is that any point inside of this solution region, a lot of you are choosing like the boundaries, like this point will work, this point will work, but like any point that's inside of here will work. 2, 2 will work. 2, 3 will work. 1, 6 will work. Any point inside of here or on the outskirts, if it is a solid line, will work for these inequalities. And that's important for you to not only understand what it means, but also how you can solve it algebraically. All right, I think that maybe we can do one more together, and then I want you guys to try a couple on your own. So flip this over. The hardest part with these, I think, is creating the inequalities from the word problem. So let's try one more together, and then I'm going to let you guys work together and try 2 on your own. So here's number 2. An online store sells digital cameras and cell phones. Do they even sell digital cameras anymore? Is that a thing? Probably really not. The store makes $100 profit on the sale of each digital camera, which they're telling us is X, and $50 profit for each cell phone they're telling us is Y. The store wants to make a profit of at least $300 from the sale of the cameras and the cell phones. They want us to write and graph an inequality that represents how many cameras and cell phones they must sell, and then they want us to do the same thing, find two solutions of the inequality. Okay, so the first thing we need to do, they already tell us digital cameras is X. I'm going to just write it here again just so I can see it in front of me. And they tell us that cell phones are Y. And then they tell us how much profit you make for a camera, how much profit you make for a phone, and how much money they want to make at least. So then we would create the inequality from this. Who can tell me the whole thing? Anyone? Eli?
100x plus 50y is greater than or equal to.
Perfect. So let's break this down. Eli said 100x because they make $100 profit for each camera. That's perfect. Plus $50 profit for each cell phone would be 50y. You add the profit together, and that's going to equal how much profit you make. He chose the perfect inequality for this problem because it says at least. I know the word least, it kind of sounds like less, but when you're making at least, you want anything equal to it or more. So they want anything equal to $300 or more in order to make that money. Once you have the inequality set up, then it's time for you to graph. And in order to graph this inequality, you're going to want to solve this thing for y. This is going to require two steps. The first step in solving for y is always moving the x term to the other side. In this case, I'd have to subtract 100x from both sides. When I do that, please realize these can never be combined together. You're going to be left with 50y is greater than or equal to. I'm going to write the negative 100x first, and then plus 300x. Okay, we good? Last step is to do what? Okay. Molly?
Divide everything by 50.
Yes, I'm going to divide everything by 50 and simplify. Negative 100 divided by 50, so just be careful, it's going to be a negative what? Yeah. And then plus 300 divided by 50 will end up being what? All right. Once we have y is greater than or equal to negative 2x plus 6, now it's time to graph. So I'm going to have to erase some of this. I'm going to give you guys a couple seconds to write this down. Y is greater than or equal to negative 2x. Or maybe I can just, no, I'll be okay. All right, so I'm going to start here at the y-intercept, which is 6. So on the y-axis here at 6, I'm going to make my point. And then my slope, I don't have to worry about converting it to anything. It's just negative 2. I go down 2 and over 1. Down 2, over 1. This is going to be a what type of line? Solid. And then the easiest point to test to figure out the shaded region is 0, 0. You might at this point kind of understand the way it's going to work though. The simple anything greater than or equal to, you might already be thinking that it's probably going to be up here, but let's just verify it by testing 0, 0. When I do that, I get 0 is greater than or equal to negative 2 times 0 plus 6. I'm going to get a false statement. 0 is not greater than or equal to 6. Because that's false, that means that this area underneath that was just the solution in the last problem is not the solution. And if you get that to happen and you get a false statement, it means the other area is the solution. So everything above here would be the shaded region, which would be the solution. That means any ordered pair above that line would be a solution to the inequality, which there's a lot more to choose from. The next part of these problems are asking you then to pick two inequalities for the solution. You can pick anything. Can somebody give me a solution that's in the inequality? Molly?
5, 5.
Yep, 5, 5. So go over 5, up 5. This right here is going to be a solution. Now we could take 5, 5. we're going to replace 5 in for x, 5 in for y, and that answer, when you do that, will be greater than or equal to 300. Like, it's just going to happen. You could check with your calculator, but it will happen. That profit will be greater than or equal to 300. And then any other point. I mean, we could choose 8, 2. We could choose anything on the line. This point here will work, which is 1, 4, because that line is solid. So anything on that line, because it's solid, or anything above it, will be a solution to this inequality. So why don't you guys try number 3? I don't think we'll have time to do number 4. So I want you to get 1 under your belt on your own with your groups. So go ahead, try number 3. We'll go over the answers before we leave class today.